I work at that difficult intersection between technology and the processes that are used. And I sit on the process side more than the technology. So I look at how technologies can be employed in manufacturing processes to create more value, increase productivity, increase profitability and margins. And I work all the way from companies in Formula One all the way down through to smaller SMEs in the hydrogen sector and to large multinationals. So my interest is really at that intersection of how technology can add value to a business, particularly in manufacturing.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. Really pleased to be joined once again by Nick Leeder, a regular on the podcast. I was going to say not just a regular, but I don't know how many podcasts you've done now, Nick. I'm always trying to count with different guests how many podcasts you've done.
I must be either 3 or 4 now together.
Yeah, you're getting onto the leaderboard now, or the podium of podcasts.
If there's a prize on there, yeah.
Exactly. Maybe I should do that as encouragement. But no, really fantastic to have you back on again. And we'll talk about industrial AI, of course, a topic close to your heart, close to our heart at Siemens as well. And it's really to dive into your experiences about why sort of industrial AI as a sort of a broader term, why those projects sort of fail, what we could do about it. We're going to talk about, you know, some of the solutions to that, of course, for people, anyone listening today can sort of take away into their own day-to-day work. But maybe, Nick, because it's probably been a little while since you've been on, and for new listeners, just a little reminder of who you are, what you do, etc.
Sure. Well, what I do is a bit of a nightmare to really explain, but ultimately, I work with a number of different companies, always around engineering and manufacturing of products and in the processes themselves. And really what I do is I work at that difficult intersection between technology and the processes that are used. And I sit on the process side more than the technology. So I look at how technologies can be employed in manufacturing processes to create more value, increase productivity, increase profitability and margins. And I work all the way from companies in Formula One all the way down through to smaller SMEs in the hydrogen sector and to large multinationals. So my interest is really at that intersection of how technology can add value to a business, particularly in manufacturing.
Yeah, it's interesting. You say in the sort of diversity of the businesses you work with. I mean, are there overlaps in the conversation we're going to have today when we talk about industrial AI and the application of AI in some of those other industries? You know, what sort of similarities and differences there?
Massively. I think, it frustrates manufacturing companies that I work with going, the business of manufacturing is actually the same, irrespective of whether you're making a one-off vehicle for a race or millions of products or bearings every year. You know, look at my background in SKF Group, yeah? And it's like the business of manufacturing is the same. The technology has the same opportunity, but you need to employ the technologies and the use cases that add the value, and that's where it differs. So, you know, I think the business is the same, the focus is the same, they ask the same questions, but the solution is not necessarily the same for all industries.
No, exactly. I mean, so I guess let's start us off, I guess, with looking at why, you know, open it up. Why do industrial AI projects fail? You know, and I guess a lot of the time we talk about pilot phases because a lot of these projects start off very small to get started and do testing. But maybe we could sort of mix those two together.
Well, I think it's worth taking a little step back and saying we're in this, let's call it a halo moment for AI, where if you're not mentioning AI in a conversation with a client, or in a manufacturing in a meeting now with leaders, you're almost irrelevant, which is absolute real shame, because there are many things we can do that don't require AI that increase productivity, and I'm sure we'll come on to some of those conversations today. And also at the same time, there's a lot of headline grabbing pieces of work that go out that create this excitement around AI, and at the same time disillusionment. So, you know, I can't, you know, I think not a week goes by where NVIDIA are not having another announcement of a relationship that they're building around AI. I think there's every company in the world is currently now a partner of NVIDIA. So everybody's going, we've got to be part of this because everybody else is. So you've got that fear of missing out moment. And I won't use acronyms, but we all know what the acronym is there. But at the same time, within like days of that, MIT put out a report that says 90% plus of AI projects are failing. So you kind of got this strange world we're living in. It's the perfect hype curve we're going through, where you've got the excitement of the halo opportunity that comes from AI, but at the same time, the reality is very, very different on the ground. And I think that is probably one of the root causes of why AI projects are not moving beyond pilot phases, because everybody's jumping in with 2 feet. They're jumping in 2 feet and going, well, we've got to do an AI project. There's a relevance question there. And then you go, okay, we're going to do this on this one thing. And that one thing, it may or may not solve the problem, but the problem is that's not repeatable. It's not scalable. They've not stood back and said, in this process, in this factory, we do it 50 times. We do it 20 times a day. Or we may have 5 factories with the same process in there with pretty similar setups. What are the opportunities to use AI? Where will it create value? And then let's focus in on that. They're jumping almost kind of straight into proving AI works. And I'm sure we're going to go into, there are, I think, some preconditions that we need to establish before AI becomes relevant. So, a great example is Rockwell came out this year, 60%, 56% of companies are piloting smart manufacturing, but only 20% are using it at scale. So to show something's working and then to prove it at scale are very, very different gigs. And the Global Lighthouse Network approach from the World Economic Forum, people need to start thinking, and they're think of assetizing use cases. So things can be reused and not rebuilt every time. And again, that's another flaw I think we've got with AI is we're kind of going in, proving it, but then we go, okay, but it won't work here, or won't do this because of X, Y, and Z. And I think there are fundamental preconditions that perhaps are being overlooked that are probably why AI is not at scale yet.
So is it a case of sort of going in and thinking about this small problem here, or is it being distracted by lots of all the different use cases for AI and thinking where to start first, or spreading yourself too thin? I've got to do everything at once, but end up spreading yourself too thin.
Well, we do see this problem of motion versus progress illusion that happens a lot. So I've recently talked about this in a couple of presentations I've given, where there are the ability to spin up 50 projects is quite easy. To actually see progress against 50 projects is very hard. So what you've got right now is that there's a lot of motion to do stuff, but progress is pretty hard. And then progress, if you're not making progress, things get killed quite quickly, or sometimes don't, which is actually another problem. But so there's this illusion there, illusion that we're creating of, if we're doing more things, we're moving forward, and we're not actually doing that. And I think also from a frontline worker's point of view, they're faced in the current environment versus say 10 years ago, they're faced with 5 times the amount of change that they've had. So there's change fatigue in the people as well. So you've kind of got this, and at the same time, because of the AI hype, we've got to do AI. And that varies between very big programs with grand aspirations and grand statements up here, all the way down to, well, we're going to use a little bit of AI, agentic AI on some SOPs down here. And it's all disconnected. A lot of companies don't actually have a fundamental strategy with a ripple down approach. And if we get into things like the ethics of AIs, the security questions, then it becomes more complicated. But right now, I think we're really at that experimental stage still. So, that formal approach and the way that we can scale is missing. That question's missing because we're experimenting. And that's good. We learn from experimentation. We're not necessarily getting value. And I think that's why you get 97% of agentic AI projects are not, according to MIT, are not actually proving any value.
I mean, some of those stats you're sort of reading off there, Nick, are really quite stark, aren't they? Especially when you consider that the hype around AI. I know, because the way you'd think of it, it's just perfection and everything's going perfectly. And I guess it's part of the sort of social media thing as well, isn't it? That, everything's talked about in such a positive light. But I guess if we dig into sort of the reasons behind it, to me, it seems like it's more than just a simple technology issue, behind this. And we're talking like people, processes, culture, and what you said before about, that gap between what's being set up here and what's being said down here. So there's this big, let's say, vacuum of information in the middle from what you've described. I thought that was quite interesting.
I mean, look, let's start with a bold statement, yeah? Automating a broken process just means you break things faster. So let's take a step back. AI requires actually processes that work. If the processes don't work, then you're automating something that's fundamentally flawed. You're using capability. So I think the process debt within companies, if you're trying to put AI over it, ultimately becomes a tax later on because it fails, because the process is broken. And it's not going to fix, let's be honest, AI will not fix a broken process. That's people with process knowledge, the data that you need. And actually, that's another key component, is that you need to think about, is the data, what data we need to make AI actually work, or your use case of AI work. And obviously, the process is the precursor to getting the right data points that you need. And again, I see that manufacturing does not suffer from a lack of data. What it suffers from is relevance of that data and context of that data. So actually pulling that together in a way that says, right, we have a good process, we have relevant data that we trust that's providing context. I think those two things, if you don't have those, then your AI project is ultimately going to be at risk. And actually, I'm actually going to make a quick call out on Senseye in the North America. They're doing the Smart Manufacturing Interoperability program process, or SMIPS. And I this is really interesting for me. Interoperability platform, sorry. So SMIP is the Smart Manufacturing Interoperability Platform by Senseye. And it looks at a number of core capabilities. And this is actually this is where you've got a world of competition and different vendors and legacy applications. By the way, this stuff is really cool on a greenfield site where you build from scratch. But most of us work on brownfield sites with legacy equipment, legacy processes. So the SMIP approach looks at connectivity. Yeah. How do you get the data from the different sources, legacy machines, systems, old historians, for example? How that data is ingested. So how, connectivity, then acquiring that together. As I mentioned a minute ago, providing the right context in a consistent way. That context gives you ultimately a springboard for scale, because a motor of a certain type in one factory, if you can then connect it and say that's the same motor in a different factory, you've got ultimately uber context that provides around that. Security of that data, the workflows that data goes through, maybe even gets enriched, and how it moves between some of the systems and the OT components you've got. And doing that in a neutral way. So we establish some standards that enable AI. I had a wonderful conversation with a company called ThinkIQ and Doug Lawson and Paul Turner the other week. It was actually last Tuesday, a presentation in London they were giving at the Quorum Principle event. That was really kind of a little light bulb moment going, why is that not there in manufacturing? And the problem with standards like this is standards are like toothbrushes, yeah? Everybody agrees we need one, but nobody wants to use anybody else's. So I'll let that sink in for a moment. Um, so I think something like that SMIP initiative by SESME is really, really important for the data and context. But actually, let's get the process right. Now, if you've got those preconditions and you've got a workforce that doesn't feel threatened or, because there's the other problem with this bubble of AI is it's a link to workforce reduction as well. That doesn't feel threatened by AI, but actually sees this as an opportunity to enhance their work. And that's your job, by the way, if you're trying to do AI projects, to position that correctly with the frontline workers. I remember we've talked about this a couple of times before about actually and making the value relevant to them and not just the boardroom. That is then the right environment that you're creating for AI projects to be successful.
Yeah, and I think as well, it falls into this again. Everything you've said is correct. It just makes you think a lot of the projects can sometimes just be sort of like theatre. It's just something to showcase that we're innovative. We're doing AI, but like you said, without some of the fundamentals, is it a case that some of the fundamentals? You mentioned connectivity, you mentioned data, like some of that's maybe not forgotten, but sort of being put in the shadow a little bit, not as cool at the moment because AI is here, but those are the things that you need to have in place to actually apply AI on top of it. That's what you're saying, right?
Yeah, it's the boring things you need to get right to make the exciting things work and get value from it. Yeah, your car, you get attracted by all the kind of sat nav and all the funky stuff you get inside of it, the self-driving features, the fact I was in one the other week, it's not mine, by the way, had a cup holder that was heated and cooled. I mean, my mind's exploding. What a great, cool feature that is. I can't think of a use case. And by the way, that's a great example of like AI kicking off. Why do you need a cup holder that chills or heats something up? But if the engine doesn't work and you don't put oil in the engine, I'm working on combustion, not electric, by the way, in my example. But
yeah,
if you don't put the boring thing and maintain that engine, the car doesn't go. So yes, you get a hot cup of coffee, but you're still stuck with where you are. And primarily, the main reason why you drive a car is to go from A to B. So if you're stuck at A, but with warm coffee, it doesn't help where you need to get to, which is to get to B. So it's always been the case with technology. Unfortunately, I've been around too long now that we forget about the boring foundation bits and we get attracted by the shiny hype. And where I am seeing AI have value is where it's being deployed in scalable use cases where they spend time and effort getting the process right, getting the data right, and then the use cases are straightforward to actually implement, and people have trust. People have trust in then what the computer says. The computer says this, and we know the process is working, the data's right, and they're able to validate what the computer is saying. That's where I'm seeing it. So things like predictive maintenance is actually those sort of use cases are scalable. You can provide very simple context and it makes the workforce's lives better. They make the operators' lives better because the machine is running more smoothly. Maintenance moves out of kind of preventative firefighting mode and into predictive modes, or the break fix world they live in. So their lives improve and things happen then from there. Importantly, there's a tangible value case to that as well. Unplanned downtime is very expensive. So it's that kind of compound effect and the environment that creates. So we move away from the theatre and we get to the practicals. Yeah.
So I mean, maybe let's go into that a little bit then, because a key component of it, everything we've talked about, what type of projects to look at it at scale as well, which again in a predictive maintenance world is important because we know the value of predictive maintenance in a Siemens or a Senseye world is, at scale. But what are sort of the measurements companies can put in place, I guess, to see this? And then we can start with predictive maintenance, but of course, maybe there's other use cases we could talk about as well. But what type of measurement could they put in place for these type of projects?
First of all, let's call out there are 3 measurements you need to put in place with these things. And the first one is a fundamental disconnect in most manufacturing companies, which is the operational metrics. So things like defects, cycle times, unplanned downtime, those things. Let's mention safety. I can't not mention safety, but those things are measured. They're often, though, measured in percentages or other values. Now, OEE is a classic there, yeah? It's measured as a percentage, which ultimately is quite meaningless as a statement. And people will shoot me down for that, maybe, but I think a percentage of nothing is still nothing, yeah? And actually, there's a disconnect then, first of all, between the operational KPIs and the board level KPIs. The harder metrics, the return on assets, net assets, those sort of things, the EBITDA statements, the financials, ultimately, which we look at. And step one is to get metrics agreed and understood at operational, but actually then establish a very strong metric connection between that and the board level kind of financial metrics the business is running. Why is that important? It strengthens the value case and the investments. So you can prove something down here, but actually show very directly how that's impacting key metrics at the board level, and the board people care about it. And that's a good practice irrespective of AI. But I think the third metric, and I mentioned this earlier on, is the relevance to the person doing the job. So how do you prove that their life is getting better? And we've talked about this. I think I did it in the Senseye kickoff earlier on in the year, but, the cost of 1 second's downtime is a meaningless figure. Even if it's in hundreds of thousands, it doesn't really mean anything to an operator. So change the language and make it relevant to them. As I mentioned earlier on, prove that the maintenance team, because of what you're doing, is no longer having to go in at the weekends and do stuff. They win their weekends back. Those sort of really simple things, those metrics are connecting operational to board, operational to people. And you create that environment when you're starting to measure the progress you're making, the impact you're having. It makes it actually relevant to all the stakeholders, not just some of them.
So actually what you talk about there, Nick, that's really interesting. If you want to call it measurement, but it's actually beyond measurement. It's humanizing. It's creating personal stories beyond it, which can be, I guess, which is important to share internally as part of an effort to scale up projects as well. So I guess that's a really effective way to get everyone bought in internally, is share some of these personal stories, not just the downtime metrics or the improved OEE or whatever it might be, but actually this person. Is that something you sort of encourage in your conversations with clients as well, sharing the personal stories?
You fell for it, hook, line and sinker, didn't you? Absolutely.
Yeah, there we go.
There we go. But it is the personal stories that make the difference. It makes a technology change human. And I think that's so important. We are all humans, believe it or not. And actually, it is those stories that inspire us, that make us actually want to do something different. So the adoption question is about inspiring people through proof that it makes their life better. And that could be the CFO's life better because he's seeing the financial metrics move in the right way he needs to. It could be the operations director because his unplanned downtime has dropped significantly. Or it could be the maintenance engineer winning his weekend back. And I think all those layers are human stories, but we tend to get absorbed in the number, not the impact it has. And I think the other thing here is the relevance of stories and who's telling them. So I recently wrote an article on LinkedIn about are we developing are people capable of only reading sat navs and or map reading? And it was actually in context to AI, but it was inspired by I think, a video of a trucker, a relatively young trucker, that's driving across Europe, and their sat nav broke, and they are so reliant on the sat nav. But then they had to try and use maps, even trying to map on routes they knew, and that really resonated with me. Going, but this is the world we live in AI today, where our dependence on AI. I use AI a lot. I use ChatGPT an awful lot, but I use it in a way that I'm still the creative spark behind it, and I use it to remove procrastination that I would normally have on writing an email. How many 15 ways you can write it? But I asked ChatGPT, I've got a version which I can edit, and I'm generally happy with. But actually, we use this as a sat nav. We get guided by these tools, and we don't think enough. We're map readers. They have to memorize a map. They have to think about the route. They have to plan that route out. It's very, very different to go on from here to here and let the computer say what it is. And you inherently trust the sat nav. And I think when I actually look at that and reflect on that in the world of AI, I was in a meeting a couple of weeks ago where we go, well, actually, we need more kind of data scientists in the manufacturing sector. And I'm like going, I don't think we do. I think we need more people that understand the process, that then can apply the data science, not having data scientists who don't know the process.
Mm.
And I think that is another massive disconnect we have, and potentially linked to AI and why projects don't scale, is we don't trust the people who know the process, who can read the maps. We trust the people who can program the sat navs and expect the sat nav to be the most optimal route. The ultimate example of this is the London cabbie that has to go through the knowledge that actually they're ultimately like your person that's been doing manufacturing in your site for 30 years, that knows everything inside out, that doesn't have to refer to an SOP. It's all in here. But they've got the knowledge. They know all the little back routes, the shortcuts to take.
So in a way, I guess with that example, in an ideal world, you bring the knowledge of a taxi cab or anyone who knows routes, even in their local area, from like the back of their hand, and combine that with technology like Google Maps and bring the two together. Then you've got almost the perfect product and the perfect balance between human and machine, if you want to call it machine, but human and software intelligence as well. I think that's.
But we get you. Exactly, and I think that is almost the perfect combination. But we get attracted by the Waze or the sat nav. There are sat navs available, but we get attracted by the technology. But what we don't think about is all the knowledge that has to be put behind it. And that's when I talked about earlier on about the process being wrong or the data being wrong, and getting those things right.
And it is interesting. It is interesting because depending on the context, so you're right. You automatically trust some technologies without even thinking about it. It's just part of everyday life. Whereas introducing it into an environment like a factory floor, for example, requires a lot more understanding, knowledge, culture change, and things like this. There's a big difference there, isn't there? I know, yeah, it's completely different circumstances. It could be personal life versus non-personal life as one example. But that's quite a fascinating look at in terms of technology adoption difference there.
And ultimately, so it's a risk reward moment. When I got my new car a couple of years ago, it's not a new car anymore, but when I got my car a couple of years ago, the guy that sold me, and I got an electric car, he said, don't use like Apple Maps, use the inbuilt sat nav, because actually it communicates with the car. It knows how much battery you've got left. It will reschedule the route. It will schedule stops that you need to make to charge. It's clever. It's an integrated thing. And I just did it. I actually just used it without even questioning it. And then you go, okay, what's the worst that can happen though? I'm 5 minutes late. Ultimately, I probably did an extra charge I didn't need to do, but Apple Maps might have got me there with 3%. This one always make sure I arrive with 10%. It's kind of, okay, the risk is relatively low. The trust in manufacturing is if we get it wrong, you might lose some money in a process. You have to do some scrap and the scrap because the quality comes out wrong. Worst case is people's lives may be at risk.
Yeah.
So actually the game is different, and therefore our trust levels have to be much higher. The proof points need to be much more solid.
No. And that's completely, you completely summed it up there. The worst you'll be with, say, Google Maps again is you might be a little bit late for whatever event you're attending or whatever, an inconvenience in the grand scheme of things. That's really interesting. I guess just the final question or thought, I wanted to talk about sort of build versus buy, because a lot of what we've been talking about today, I think, is about adopting various different AI technologies. But have you been hearing a push around a lot of building internally? And we know there's tools now that can spin up products or at least early versions of products very, very quickly. But are you hearing more in that direction in recent times, Nick, around building AI products internally?
It depends who you speak to, I think, is the ultimate answer.
Exactly.
So you speak to the IT guys, the IT people. I shouldn't, subconscious bias kicking out there, but the IT people. And what you find is that the build attraction is quite high. Yeah. Whereas if you speak to operations management, they just want to buy something that works. So that build versus buy is actually very much driven by the personas. Engineers are engineers. So inherently the build question, the experimentation questions are very high. But you have to take into account the cost and what you're trying to prove. So all the conversation we've had already in this here, if you start with all the negative context and then try and do it yourself, the probability of successful outcome is low. And then this question of scalability makes that probability of successful outcome even lower. Point solutions that require some very specialist knowledge, if you have that knowledge inside, is fantastic. But that's not a question of, you open the whole coal up around scale. So commercial off-the-shelf solutions that have proven solutions that know the conditions that it works in as well, that means your time to value is significantly reduced by then trying to develop it yourself. But again, I put the use case flag on. If you've got very specialized processes that require specialized inputs, then maybe the commercial off-the-shelf or COTS solutions might not be the right way forward. But what I am seeing is the balancing act of a trend here of platforms. Again, we've gone through this through IoT as well, yeah? We start off with ideas of what we could do. We move to platforms, then we end up with solutions, and then we go back to platforms. There's a cycle that goes on here now. My prediction is AI is kind of going solutions to it's on that platform move now. Maybe we'll go back to solutions again. Let's trust the world of cyclic things that have happened before.
Interesting. But I think it ultimately comes down to, again, because a lot of time, I think building internally, there's a lot of internal expertise where we think, well, we've got all this expertise, whether skills or knowledge, we can build it ourselves. But again, back to the point before about bringing stuff together, you've got, whatever vendor, years of experience, great individuals who can really help you in an external part, bring them together with your fantastic internal teams and not create something together, but create a joint solution together that's scalable and can make an impact. So it's actually, again, the benefits of coming together with different, and not just one vendor, actually, it could be multiple vendors. So we're talking about a partner ecosystem as well, of course. But yeah, so, the benefits are clear to that, right?
Yeah, and just because you can doesn't mean you should. I could build a kit car if I really wanted to, but I go and buy one because it's actually a lot quicker to get me from A to B. Yeah. So, but if I had to build a hill climbing car, the likelihood is I wouldn't go out and buy a commercial off the shelf vehicle and try and modify it. I'll probably build one specifically for that purpose. So I think, it's the tools to do the job is ultimately the question statement I'm making.
Yeah. Ultimately, it's what problem you're trying to solve, and then you can look at whether building or buying the solution is applicable in that particular circumstance, right?
And I think timing, like I mentioned right at the beginning of the call, we're on a hype curve. So a year and a half, 2 years ago, the world of AI is moving incredibly fast. There probably wasn't many solutions out there that were at scale that are proven. Now, still there's question marks around those statements, but now there are probably a lot more, given the hype, a lot more solutions you could look at from the big players that you can now assess, that probably more platform centric than trying to do things from scratch, where 18 months, 2 years ago, the landscape looked quite different.
Absolutely. And in a way, it's a good point to end. I mean, the only thing as we usually do on here, and what we've done before, Nick, is sort of just end with some takeaways for the audience as well. So, Fingers starting an industrial AI project. They want to be able to get buy-in internally. They obviously, they're thinking about scale as well. So they're not just thinking about, maybe the short-term vision, but the long-term vision. But what sort of 3 quick areas they should sort of consider before launching into an industrial AI project?
So if you're going to launch into an industrial AI project, which clearly wasn't very easy to say for me, first question I would ask is why? Why is it an industrial AI project? Should it not be a process improvement project that gathers the right data, which you can then employ AI on? You might have got the question, you may have got the answer before the question. So that's my first fundamental point. If you can explain why you're going to do an industrial AI project, then make sure that the use case you're solving is repeatable. I've seen a lot of AI projects that solve the use case once and the problem once, but the problem then doesn't repeat itself. That doesn't get you to scale. So it's a repeatable, common problem, and it applies to multiple lines, multiple factories you've got in your network. And then make sure the measurements are right. You can demonstrate value. You demonstrate value operationally, demonstrate value at an exec level, but also make it relevant to the people you're impacting. My final point is, and don't expect this to be start on a Monday and by Friday you've got the answer. These things take time to get right. So set a realistic time frame to achieve these things in, and do it in a way that doesn't break the current processes, but enhances what you're doing as you're doing that step by step.
Oh, excellent. Yeah, it's about, and don't try and use AI, I guess, to fix processes already broken. I just like that, what you said earlier on as well. AI is not going to fix a bad process, right, as well. So it's that's another thing to consider.
Yeah, absolutely.
Fantastic. But no, thank you so much, Nick, for your time today. Very, very generous of your time today. We've gone over a little bit, but it's been really great to have you on again. And I guess this episode will go out in the new year. We're talking sort of late December now, but happy Christmas and New Year to you.
I should have put the Christmas tree in the background.
Exactly.
But when we recorded it.
Exactly. But no, it's been a pleasure having you on again, and hopefully have you on again in the future.
Thank you for having me. I really enjoyed the conversation, Niall, and I'm always happy to come along and have a chat with you.
Fantastic. So yes, thank you to you, Nick, and thank you to everyone out there for listening, wherever you are, and we'll see you on the next episode.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.